All right, Noah and Olivia. For our lesson today, what we're going to be dealing with is what's called graphing inequalities. Now, for inequalities, they can seem kind of, maybe a little bit scary at first by hearing them and understanding them. But understand, all you're doing is you're graphing the following comparison symbols. Now, here are two that we're very familiar with. Less than as well as greater than. Make sure that less than is always going to be that bent L, and then the greater than is always going to be, think about teeth as well. You could do that as well if you have to make sure. So less than and greater than. But then we add today is less than or equal to or greater than or equal to. So when we talk about inequalities, what that it's dealing with is it really has more than one answer. So variables that we had, for example, we had things like x equals 3. Now, keep in mind, x equals 3 means that there's only 3. But what if we had something like this? X less than 3. There's going to be more than one solution to that. That's what makes this an inequality. It is something that's showing that the variable of x has more than one solution. So when we graph them, we have to show all of the different solutions. But before we actually graph on our number line, we need to make sure that we understand what does it mean to graph. Now, for these ones right here, so the less than and greater than, what we're going to have on here, and I'm going to try and do this as you have what are called open dots. It means that, for example, you look at, we have x less than 3. 3 cannot be less than itself. That's something to be aware of, and it's something for your ears to hear. X less than 3. 3 can never be less than itself. That's why it's an open dot. But if we have the less than or equal to, try to get where there's no shadows. These are going to be closed dots, okay? Because if we had x less than or equal to 3, that means that it also can be 3. So let's take a look. So we have our number line here. We have x less than 3. Okay, looking at the top, we can see, all right, so we have our dot needs to be on 3. Okay, open dot on 3, but less than. This can be the challenge, because how does this solution work? Now, let's take a look. So let's try our first one here. Let's try 4. Is 4 less than 3? Hopefully you realize that can never be true. 4 can never be less than 3. So that means all of the numbers to the left are less than 3. So what we do is we then put an arrow on the number line, and they show that all of the solutions, all of them, even into infinity on this number line, are less than 3. So here, the graphing solution is this, x less than 3. Now let's go to this next one here, okay? X greater than or equal to negative 3. All right, so here we have negative 3, okay? All right, this tells me, all right, I need to do it. It is equal, so it's a closed dot. But take a look. All right. For this solution to be true, then it must also have all of the solutions be included. Now, is negative 4 greater than negative 3? Now, hopefully, as you remember, that the further away from 0 you get, the smaller the value is. So that means that negative 4 cannot be greater than negative 3. That means all of the numbers that are to the right